Hi guys, welcome to my channel once again, and today we're going to show you assignment 3, that is path planning using a tool-link robot. This is our assignment 3, and this is the code that I have for assignment 3, and I'll explain it to you in detail. If I click on the run button over here, okay, so this is the GUI model that I have, and if you see there's a create robot over here. These are from the last assignment, and this set is the new one. So if you see, I have interpolation, 3 methods, and then I have the path planning generation method as in D star and PRM. These are the two algorithms that we have used to generate the shortest distance between 2 points, the starting and the end position. So if I click on create robot over here, it will create the GUI model of my tool-link arm, and if I create a D star, this will basically give me the path that I have planned. So this is the path that I have planned according to D star. It starts from a 20-20 and ends at a 50-60, 60-50 actually. And this is for the D star, and I'll show you for PRM. I have the hardware connected, so okay, so I'll show you for the PRM. PRM basically gives you a lot of probabilistic maps, and if I click on PRM over here, it'll give me a lot of probabilistic paths from the start to the end position. If you see, all of those are in black, and the one in crimson over here, this path is the one that is the shortest path between all. It's something similar to D star, but actually a little different over here because it gives you a more curve towards the end of the path. So this is what we have for PRM, and I'll just show you how this would run on the robotic axis, the GUI. And if I create this again and click on D star, it's going to generate the map first, and then it is going to give me a GUI model. So this is the path that I have decided for my robot, and if you see, it starts from somewhere. Basically it's a little small because of the scale, and it starts at a 20-20 and ends at a 50-60. This will be the end point over here, and the obstacles in the middle would be avoided. So this is what we have for D star, and so I'll show you all 3 interpolation methods, and these are the 3 interpolation methods. This would generate again a path for. This is a smoother path. If you see, the obstacles would be avoided and will give a smoother map. It will give a smoother curve towards the bending portion of the path. If you see here, it gives a smoother curve towards the end. Similarly, mtraj and T-poly, LSPB, and all the other interpolation methods generate a similar path, a smoother curve. If I click on T-poly, it would again give me basically D star algorithm again, and then it will generate a smoother path once again for my robot. If I can move it and show you, so it generates a smoother path. It's a little small because the values that we generate over here fall, because the length of the robotic arm is somewhere within the 10 centimeter range. That's how we set it. So the scale is a little smaller, but you can definitely write a few lines to zoom in and then see the exact path with a smoother trajectory. So this is what it gives you, and hardware, it would generate a similar path towards if I click on create robot and then I click on the star, so it will go to its original position and then it'll run the path, and then it would generate a small little curved pencil. I don't know if you can see it, but it generates the path, and towards the end when it's gonna move up, if you see, it moves up over here. So it's basically not to scale because of the values that we have. They're basically smaller and basically to a 10 centimeter range, otherwise the robot would go out of limits, and this is how you can generate a path and make your robot move. So this is all we have for you today. Thank you.